Okay, so we are going to start with volumes of prisms and cylinders. And we know that volume is the amount of space that a figure encloses. It's the amount of water you could pour into something. It's the amount of stuff inside of a 3D shape, right? That's what volume is. And we're going to start with prisms. So this is a rectangular prism here, but this formula actually goes to any volume of any prism. And the formula is the area of the base, which we represent with a big B, times the height of the prism, which is little h. Now, what's going to be crazy is that the area of the base changes, right? If my base is a rectangle, my area is going to be length times width. If my base is a triangle, it's going to be 1/2 base times height. So just changes formula each time. Okay, so here we go. Volume of each prism, round to the nearest tenth if necessary. So on a rectangular prism like this one, typically, it doesn't technically matter, but typically we go with the top and the bottom being the bases. So let's make these yellow ones. So it's the area of one base, area of the base, times the height. And remember that your height is the distance between the bases. So what number would represent the segment connecting the two bases? In this case, it's the 3. So the area of the base is the 5 times 8, because that's a rectangle, so we do length times width. And then the height of this prism is 3. So 40 times 3, that's going to be what? 120. And keep in mind, now that we're doing volume, you're doing inches cubed. Okay, so let's try something else. Let's go to this triangular prism. Now, typically, this didn't apply in the first one because it was a rectangular prism, but typically in a prism, your bases are the non-rectangles. So the first thing I would recommend doing anytime is identifying which sides are your bases. In this case, it's going to be those triangles because triangles are not rectangles, right? So when I say volume is area of the base times height, I'm finding area of a triangle times the distance between the triangles, the distance between my bases, right? That's what height is. So in this case, my height is the 9. It looks like there's a couple of different strategies for finding the area of one of these triangle bases. We could use 1/2 base times height if we wanted to, or we could also use 1/2 AP because it looks like it's equilateral. All 3 sides are 5. So I'm going to go with, since it's equilateral, I know that all 3 angles would be 60. So if I were to draw in my altitude, so by the way, I'm going the 1/2 base times height. Keep in mind there's 2 separate heights in this formula. This is height of the 3D prism. This is the height of the 2D triangle, right? So the base of that yellow triangle is 5. The height, I'm going to have to use my 30, 60, 90. So I'm going to bust up that 5 at the bottom into 2.5 and 2.5. If across from 30 is 2.5, across from 60 would be 2.5 root 3. And then my height of the prism, we said, was 9. So I'm going to stick that all in my calculator, and that comes out to be approximately 97.4. Again, our units are cubed, not squared now. All right, so now pause the video, try yourself. It's a lot like Part B, and then let's come back and look at it together. Okay, so we do have, our formula is volume is area of the base times height, and keep in mind that's the height of the 3D object, the distance between the bases. I've identified my non-rectangles, my bases, to be the 2 triangles on either end, so keep in mind bases do not have to be top and bottom of the shape, just the shapes that are not rectangles. And my height, my distance between my bases, is that 9. So here we go. So area of the base, just like last time. Here, I'm going to draw that yellow triangle over here. All those angles are all 60 again. Again, it seems to be equilateral because that 3 feet really goes right there. And so 30, 60, 90 triangle, we're going to bust up that 3 at the bottom into 1.5 and 1.5. So if across from 30 is 1.5, then across from 60 is 1.5 square root 3. So 1/2 base times height for my two-dimensional triangle times the 9 for the height of the prism is 1/2 times 3 for the base times the height, which is 1.5 square root 3 times 9. So put all that in your calculator. And it comes out to be 35.1 approximately. Okay, so I'm going to stop this video here and I'll pick up on the next video.